हेलो एवरीवन, वेलकम टू ओकुल। तो आगे बढ़ते हैं। लेट्स कंटिन्यू विद दिस कोर्स ऑन थ्योरीज ऑफ मशीन सिंपल मैकेनिज्म पार्ट 1. इन द प्रीवियस वीडियो you have seen about the syllabus and the basic sources which are to be followed for this subject. Okay, so from today we will be starting with this subject of theories of machines with this topic of simple mechanisms part 1. Okay, so let us begin. Let us see first of all what is a kinematic link or an element. Okay, so every part of a machine which is having some relative motion, okay, there should be a word some relative motion with respect to some other part is known as a kinematic link or element. Okay, तो कोई भी पार्ट या कोई भी मशीन का ऐसा पार्ट has some relative motion कि जिस भी मशीन के किसी अदर एलिमेंट्स के साथ जिसका कोई रिलेटिव मोशन है उसको बोला जाएगा काइनेमेटिक लिंक और एन एलिमेंट. ओके, नाउ इट इज नेसेसरी फॉर द लिंक टू बी अ रेजिस्टेंट बॉडी. याद रखेंगे द इंपॉर्टेंट प्रॉपर्टी ऑफ एनी लिंक दैट it must be a resistant body. Why? So that it is capable of transmitting power and motion from one element to the other element. अगर link is not resistant, अगर जो link है वो resistant नहीं होगा तो क्या होगा? It will not be capable of transmitting power and motion from one element to other element. So the necessary condition for the link, that is, it should be a resistant body. Okay, now let us see what are the types of links. First is rigid links. These links deformations are negligible. In these links the deformations are negligible. Examples are crank, connecting rod, piston, cylinder, etc. In this the deformations are negligible, hence they are called as your rigid links. Okay, next है आपका flexible links. Flexible links किनको बोला जाता है? Those links in which deformations occur but within permissible limits. तो deformation होगा लेकिन बहुत ज्यादा नहीं होगा. इट विल बी विद इन परमिसेबल लिमिट्स. द एग्जांपल्स आर बेल्ट ड्राइव, रोप ड्राइव, एक्सेट्रा. ओके, नाउ कम्स द थर्ड टाइप ऑफ लिंक, दैट इज योर फ्लूइड लिंक. नाउ हाउ द फ्लूइड कैन बिहेव एज अ लिंक? ओके, फ्लूइड कैन बिहेव एज अ लिंक व्हेन पावर इज ट्रांसमिटेड बिकॉज ऑफ फ्लूइड प्रेशर. जब ऐसा होगा तो देन फ्लूइड बिहेव्स एज अ लिंक. एग्जांपल इज योर hydraulic brakes, hydraulic lift, hydraulic jack, etc. Now here you can see the example. Here this is the input link. Okay, there the force is provided input side. Okay, and in this this fluid behaves as the link and it transmits the motion or the power to this output link. Okay, so therefore here the fluid behaves as a link. So this is an example of a fluid link. Okay, next is your types of links, that is binary links. Those links which are connected at two places. Suppose this is any link, this can be connected either at this place or at this place. Okay, since it is connected at two places, one at this and another at this, we can say that this is a binary link. Okay, second comes your ternary link. What is a ternary link? Those links which are connected at three places. Okay, this should be three places. Suppose we have any link of this sort. This is any link. It can be connected one at this place, one at this place and another at this place. Okay, so these are the three positions or three places at which this link can be connected. So it is known as your ternary link. Correct? Now comes your third type, that is your quaternary link. Those links which are connected at four places. Again this is places, four places. Suppose you have this sort of a link. Okay, this can be connected at four places like this. Okay, 1, 2, 3 and 4. Okay, so these are the four places at which this link can be connected. So this is your quaternary link, and this can be connected at three places like this, 1, 2, 3. So this is a ternary link, and this is a link which can be connected at two places. So this is your binary link. Okay, I hope ये आपके समझ में आया होगा. चलिए आगे बढ़ते हैं. Types of relative motions. Now let us see what are the types of relative motions. First important thing is, for the relative motion to occur, system must have two links. Okay, याद रखिएगा, बहुत इंपॉर्टेंट है कि मोशन के होने के लिए, for the relative motion to occur, system must have two links. दो लिंक्स होने चाहिए. Okay, दो कौन कौन से होने चाहिए? One link is the link whose motion is to be observed. एक लिंक ऐसा होना चाहिए जिसका हम मोशन ऑब्जर्व कर रहे हो, और another link वो होना चाहिए जिसके रिस्पेक्ट में हम मोशन को देख रहे हो. Okay, so another link is the link with respect to which the motion of first link is observed. Okay, so Now there are different types of motions. Let us see them one by one. First is your constrained motion. Okay, constrained motion, constrained means it's a desired motion which we want from the system. Okay, so when we apply an input and receive the desired motion or the desired output motion, then the motion is called as your constrained motion. तो जब हम कोई इनपुट देते हैं और हमें अगर उसका desired output मिलता है, okay, desired output मिलता है, तो we say that that motion is a constrained motion. अब इस constrained motion में भी different types हैं. There are different types in this constrained motion also. Like your first one is completely constrained. Okay, what is a constrained motion? That we have understood. Now let us see what are the ways through which any motion can be made a constrained motion. Okay, so first is your completely constrained motion. When the motion is constrained by the system properties, then it is known as completely constrained motion. Okay, see the example. See the example. See, suppose this is any square shaft. Okay, this is any square shaft fitted inside a square hole. Okay, so now this shaft can only do a reciprocation motion or a translation motion, but it cannot do your rotational. Okay, the rotation is not possible. The rotation is not possible. So the motion, that is the translation motion which we are receiving or which we are getting as an output, which is the constrained motion, is only due to your system properties. So this sort of a constrained motion is known as your completely constrained motion. Okay, now if we see this type of a motion, that is, there is a circular shaft but it is fitted with a collar. Okay, this is your collar. So it is fitted with a collar. Now this shaft, first of all, if this shaft does not have a collar, then it can do translational motion as well and it can do the rotation motion as well. But due to this collar, this translational motion has been restricted. So only now what the shaft can do, this circular shaft inside the circular hole, what it can do, it can only do your rotational motion. So now the motion has been constrained again due to your system properties. So again, this is the example of your completely constrained motion. Okay, now let us see your another type of a constrained motion, that is your successfully constrained motion. Okay, now when the motion is constrained by the surrounding properties. Okay, please remember यहाँ पर आ गया है surrounding properties. Now when the motion is constrained by the surrounding properties, then it is known as successfully constrained motion. बहुत बढ़िया एग्जांपल है इसका. Let us see. Say, first of all, we have only these two links, that is 1 and 2, that is your piston and cylinder. Okay, forget about this third link, that is connecting rod, for the time being. Okay, so if we have only two links, that is your piston and cylinder, so what all motions are possible? Piston can do our translational motion, okay, and piston can also rotate inside this cylinder. Okay, so this motion is not constrained because for a single input we are getting two outputs. So this motion is not a constrained motion. Okay, so now to make this motion a constrained motion, we attach the piston with the connecting rod, which is being shown by link 3 here. Okay, so now when this is being connected by our connecting rod, then what happens? The rotational motion of this piston inside this cylinder has been restricted. Now only what will happen? Only your piston can do a translational motion or reciprocating motion inside your cylinder. Okay, so now the motion has been constrained, and the motion has been constrained by the connecting rod, which acts as the surrounding for this piston cylinder arrangement. So we will say that this sort of a constrained motion is your successfully constrained motion. Okay, समझ गए सब? चलिए आगे बढ़ते हैं. Let us proceed. Now another example is shaft in a footstep bearing. Okay, see, if this is the shaft, that is your shaft shown by the link 2, and this is your bearing, that is on shown by 1. Okay, so now if this is the only case, now the shaft can do your rotational motion as well, and the shaft can do your translational motion as well. So again, this is an unconstrained motion. Okay, so we have to make it a constrained motion to get the desired output. So what we do, when the engine block is kept over this, okay, so then its reciprocation motion or translational motion is restricted. Now only rotational motion is possible. So this engine block acts as again the surrounding for this system of the shaft over the footstep bearing, Okay, so this motion has again been constrained by the surrounding properties, hence it is known as your successfully constrained motion. Okay, then comes your case of a syringe. Okay, again this is a very similar case as of your piston cylinder arrangement only. Okay, shown by this cylinder, okay, as 1, and this is your plunger as 2. Okay, now when we see this plunger is again possible, is able to rotate this way, okay, and also able to go in this direction, that is the translational motion. But again this is an unconstrained motion. Now to make it a constrained motion, what will happen, we will use this way. Okay, we have this sort of arrangement. So what we do in the case of a syringe, we just make this motion restricted and we just allow this motion. Okay, so only this motion is allowed. So what happens when only your translational motion or reciprocation motion is allowed? So again this part, that is the force that we are applying from our side, that again becomes your surrounding. Okay, that again becomes your surrounding. So again the motion has been constrained by the surrounding properties, hence this is again a successfully constrained motion. Okay, I hope this is very clear to you. Don't ever get confused between your completely constrained motion and successfully constrained motion. Okay, now let us see what is a kinematic pair. Any connection of two links is always a joint or a pair. Okay, any connection of two links is always a joint or a pair, but this pair will only be a kinematic pair when the relative motion between the links is a constrained motion. बहुत जरूरी है, बहुत important है. Any connection is always a joint or a pair, but this will be a kinematic pair. This will be called as a kinematic pair only when the relative motion between the links is a constrained motion. Okay, I hope you get it. Okay, and then if it is not the case, that means if we do not get a constrained motion, that sort of, or if we say it in this way, that if we do not get a desired output motion or desired output result from the input motion, then we can say that that sort of a motion is an unconstrained motion. As if you have only a circular shaft placed inside a circular hole, then it can do both sorts of motion, that is this reciprocation as well and also the rotational as well. So that sort of a motion is your, which motion? That sort of a motion is your unconstrained motion. Okay, now let us move on to the classification of kinematic pairs. First is the first way or first means by which we will classify this, that is according to the type of relative motion. Okay, first one in this category is your turning pair, which is also called as a revolute pair or a pin joint. Okay, in this the relative motion is your pure turning. What is this? Let us see. See, this is this is one link, this is another link, they are jointed by a pin joint here. So now these links can only do one motion, that is this sort of a motion, that is a rotational motion about this link. Okay, about this pin joint, so this becomes your turning pair. Okay, second one is your sliding pair, which is also known as a prismatic pair. When the relative motion is pure sliding, suppose you have any surface this sort and this is any body that is kept over it, this can only slide over it. Okay, this can only slide over it, so this is known as your sliding pair. Now moving ahead, we have another type of a pair that is known as a rolling pair. When the relative motion is pure rolling. Okay, pure rolling means rolling without slipping, okay. So now if this is a body, this is a roller, this is rotating over a plane surface, so it will only rotate. Okay, it will only rotate. So if this is the eye center, this we will look in a detail in the chapter of velocity analysis. Okay, so if this is rotating this way, so what it will happen, this position will be at rest. Okay, that is known as an eye center. Don't worry about that concept, we will look into it in a greater detail in the topic of velocity analysis. Okay, so if this is a pure rolling, so this kind of a rolling pair is known as your rolling pair. Okay, next comes your screw pair. When the relative motion is over the threads, that is your nut and bolt case, that is known as your screw pair. Okay, next comes your spherical pair, which is also a ball and socket joint. When the relative motion is a three-dimensional rotation like your spherical motion. Okay, ball and socket joint, you know that you have seen, this is a very common example, you might have seen your joystick and all those things. So in that case, the motion which is possible is your 3D rotation or spherical motion. Okay, and that is known as your spherical pair. Now another way of classifying the pairs is according to the type of contact. So if we have a lower pair is when we have the surface contact between the two links. Okay, higher pair means when we have the point or line contact. Okay, then another comes in this category only, that is your wrapping pair, when one link is wrapped over other link. Okay, when we have your multiple contact points, that is known as your wrapping pair. Okay, now see here one case. This is a very important concept that is given, that is one higher pair is equivalent to two lower pairs. Okay, this is a higher pair. You can see that there is a point contact here. Okay, point or a line contact depending upon the shape of this follower. Okay, and to eliminate this higher pair, we introduce this sort of arrangement. Okay, and we got there, this is a pin joint, so this becomes a lower pair. So when this higher pair is equivalent to two lower pairs, because by this same motion, to get this same motion, we use two lower pairs, one here and one here. So we can clearly say that one higher pair is equivalent to two lower pairs. Okay, now different types of joints. Let us see what are different types of joints. First one is your binary joint. Okay, where two links are connected, that is your binary joint. Suppose this is your link 1 and this is your link 2 and they are connected here, so this becomes your binary joint. Okay, but please remember, these two links also here are your binary links. But suppose, what if we have one link as your ternary link and another one as your binary link, but still this is your binary joint only. Okay, please don't get confused. Binary joint means where two links are connected irrespective of the type of link, whether the links are binary, ternary, quaternary, whatever. If they are connected if two links are connected at one place, that joint is known as your binary joint. Okay, second comes your ternary joint, where three links are connected, that is your ternary joint. Suppose this is link 1, this is link 2, this is link 3, they are connected here, so this is your ternary joint. Okay, one link, two link and three link. And one ternary joint is another, again equivalent to your two binary joint. Here we have 1 2 as one binary joint and 1 3 as another binary joint. Okay, so 2 3 automatically comes into contact or automatically becomes our joint. Okay, so 1 2 and 1 3, so you can clearly say that one ternary joint is equivalent to two binary joints. Then comes quaternary joint, where four links are connected, that is your quaternary joint. Suppose this is link 1, this is link 2, this is link 3, this is link 4. Okay, so this is your quaternary joint because there are four links connected, that is your quaternary joint. Okay, clear everyone? And one quaternary joint is again equivalent to one binary joint, as in this case you can see 1 2 1 3 1 2 1 3 and we can say 2 4. Okay, 1 2 1 3 and 2 4. 1 2 connected, 1 3 connected, so 1 3 becomes connected, 2 3 becomes connected, and 2 4 connected, that means 3 4 also becomes connected. Okay, now let us see what is a kinematic chain. Let us see this. If all links are connected in such a way that is the first link is connected to your last link in order to get the closed chain, first condition is this. And if all the relative motions in this closed chain are constrained, then such a closed chain is called as your kinematic chain. Very important. If the links are connected in such a way that the first link is connected to the last link in order to get the closed chain and the relative motions in this closed chain are constrained, then such a closed chain is called as your kinematic chain. Clear? Now, first of all, we have a kinematic chain, that is a constrained chain. Now to use this chain, one link must be fixed. This is a very important condition. And when from the kinematic chain one link is fixed, then it becomes a mechanism. So for the condition, for any kinematic chain to become a mechanism, the major condition or the most important condition is that one link must be fixed. Okay, now when it becomes a mechanism, it gives the desired output with respect to the given input. Okay, and when we utilize that mechanism, we get a machine. Okay, so from here comes the concept of machine. So now we are basically, we can say that we understood what a machine is technically. Okay, and this machine is going to give us the desired output. Okay, so I hope this topic is very much clear to you. We have just started with the topic of simple mechanisms. So if you haven't subscribed to our channel, please do it at the earliest and also press the bell icon to get the notifications of our new videos from time to time. Okay, and if you have any comments, any queries, any doubts, that you can write to us on the comment section below, and also you can join us on our Facebook page Twitter page, Telegram channel, or our website, or you can also contact us through our email. Okay, all these links are given in the description below. In the next video, I will be covering some more concepts related to your simple mechanisms, and then we will see the different types of mechanisms, the major important concepts like your degrees of freedom, the Grashoff's law, and all are coming in the subsequent videos. So till then, like this video, share it with your friends, and stay tuned for the next video. So see you in the next video. Thank you and have a nice day.